So, can you please share three most inspiring innovations that have recently happened in AI that have influenced you a lot?
So I will preclude that by asking how recent. So what's recent to you? Um,
I think last 2 years, since the era of GPT
there are a
4
few.
or
All
GPT
right.
3.
Okay. So I think some of the things I'm most excited by. The first one is alpha geometry, which came out in January. I think it's super exciting. It is a machine learning model that uses large language models as well as some traditional symbolic methods, and basically is able to solve IMO geometry problems, which are super difficult and is just a crazily difficult task. And the performance that we have seen in those models is like amazing. So I think that's really exciting. So solving IMO math problems using AI. The second sort of main innovation that I think was also really exciting. So it goes back a bit further. It was using similar techniques for program synthesis, which is the sort of the task of generating code using machine learning models, and as well as other like traditional methods. So I think a good hybrid example of this was Dreamcoder. And the third the exciting project that I've discovered was updating Dreamcoder using large language models. So you swap out the one of the components in Dreamcoder using an LLM, and then you get like amazing boost in performance. And that paper was called Lilo. So Lilo, Dreamcoder, and Alpha Geometry are sort of the three like advances in AI over the past few years that I think are really cool and really amazing. And they sort of like led to each other. So Dreamcoder's architecture influenced Lilo, and then we see like LLMs being adapted more and more across different tasks. So that's where alpha geometry came in with the math domain. So yeah.
Incredible. Would you define Dream Coder similar to GitHub Copilot to generate code?
I think the main difference in Dreamcoder is so Copilot is what I think the architecture of Copilot broadly is mostly LLM focused and LLM based. Dreamcoder had a very simple neural network. Like it does not use billions of parameters. It does not use like a large language model at all. And the idea behind a Dreamcoder is basically to have like have a neural network that is used for a sort of predicting which chunks of code are like good, like in terms of solving a particular problem or a particular task. But there's like other systems that are working to constantly refactor the code and come up with basically good submodules. And so the main power of Dreamcoder is not really generating like long strings of code to solve a problem. It's basically finding like useful tactics or techniques, which are these small submodules that you can chain together in order to like solve like a crazy like big problem. So a quick example of that would be like, for example, if you're trying to devise a sorting algorithm, the first thing that Dreamcoder does is like try to find a simple like sort of piece of code that can like swap different elements in an array together or something, right? And then you combine those, like what sequence do you do the swaps in? What are the conditions under which those swaps occur? And so it keeps iterating on these and sort of filling in these holes until it comes up with a complete sorting algorithm from beginning to end. And it can do that knowing just like the programming language that you're using and the task that like the input and output for the task that you're trying to solve. And you would not need to train it on you don't need to train it on the whole of GitHub. You don't need to train it on like all these like large code bases. And so I think that's really powerful.
So it's more of algorithm than AI and LLMs, right?
It is a neurosymbolic model. So it uses like a neural network to do the
All.
prediction. So it has some AI in it, but the refactoring is done by algorithms. So there's a lot of like program analysis research that is used in order to find what is like a good program or a good solution.
And what was the third one you said?
So the third one is called Lilo. Lilo substitutes the one of the ideas behind Dreamcoder is just enumerating a lot of programs and checking them to make sure that like which ones work, which ones don't work. And so Lilo swaps one of those, amongst other things, swaps out the enumerator using an LLM. So the idea is that the large language model is generating some of these abstractions and like rewriting this code so that it becomes more understandable to humans and also helps the model learn how to solve these problems much faster. So that's the main idea. Yeah.
ये थर्ड पार्ट को थोड़ा सा हिंदी में ब्रेक कर सकते हो?
ठीक है
थर्ड, हाँ,
ईमेल कैसे
मतलब थोड़ा सा हिंदी में मुझे इतने अच्छे से समझ नहीं आया. I'm sorry.
अच्छा अच्छा ठीक है ओके सो बेसिकली आइडिया ये है कि अगर हम तो एक तरीका है एलएलएम्स का जिसमें हम सारे लाइक प्रोग्राम्स को हम एनालाइज कर रहे हैं थ्रू वन मॉडल, राइट? एंड देन हम ट्रीट कर रहे हैं उसको जैसे कि नेक्स्ट लाइक टोकन प्रेडिक्शन टाइप ऑफ टास्क है, कि नेक्स्ट लाइक क्या टोकन है सीक्वेंस में विच वुड कंप्लीट द प्रोग्राम। इन अदर सेकेंड टाइप ऑफ मॉडल्स में क्या है, यू ट्रीट अ प्रोग्राम एज समथिंग दैट हैज होल्स इन इट एंड यू ट्राइंग टू फिल दोज होल्स। तो जैसे एक फंक्शन कॉल मिसिंग है, ठीक है, वहां पे फिर क्या इंटीजर आएगा, स्ट्रिंग आएगा, क्या आएगा वो फंक्शन कॉल में। So you fill that in and you keep chaining these functions together like more functional programming type of approach. तो उससे फिर क्या होता है, एक सीक्वेंस ऑफ फंक्शंस बन जाता है, और वो सीक्वेंस ऑफ फंक्शंस कैन सॉल्व योर टास्क। सो यू कैन राइट एन इंसर्शन सॉर्ट बाय चेनिंग फंक्शंस टुगेदर लाइक यू डू इन लिस्ट, और यू कैन राइट इट लाइक एज अ पाइथन, लाइक मतलब हर एक सिंटैक्स को याद करो, लाइक मॉडल से सिंटैक्स सिखाओ एंड ऑल दैट। सो दोज आर द टू डिफरेंट अप्रोचेस।
समझ गया. So to give some background to the audience, so there is, these LLMs are based on supervised learning. जैसे अगर आप hello, or let's say you train a model based on a name like hello apple, hello orange, and now next time you're trying to predict, if you just write A, it'll automatically say apple. That's how supervised learning works. Now you are breaking it down into chunks of code and then training on top of that, right?
Yeah,
To
so the
supervise.
idea,
Supervised
yeah.
or unsupervised?
So this is more, I would say, is like a hybrid approach. So you have some idea of what a good solution to a task is, right? So you have obviously like एक input array है, उसका एक sorted version है. So like that is your input output definition. But unlike your LLMs, you're not giving it the full code required for sort. क्योंकि sorting का code LLMs के like data में already है. And so it can like figure out a new sorting algorithm or like discover a lot of cool things from like actually cut that part. I guess new sorting algorithm का वो थोड़ा unproven. But what I was saying, so what it can do is it can examine the code it already has in its data set. और फिर उससे it can like generate, like if you give it a task like oh generate a sorting algorithm for me, it can reference that and generate you a sorting algorithm. In this case, sorting algorithm में हमारे पास कोई actual code नहीं है in between, like in our training data set. हमारे पास unsorted, बस एक task है which says this is an unsorted array, this is a sorted array. अब आप फिगर आउट करो कि ये लैंग्वेज के अंदर हम इसको अनसॉर्टेड एरे को सॉर्टेड एरे कैसे कन्वर्ट कर सकते हैं, एंड दैट द मॉडल कैन लर्न टू डू ऑन इट्स ओन। थोड़ा उस एरिया में अनसुपरवाइज्ड है कि हम उसको बता नहीं रहे कि क्या व्हाट इज अ गुड एग्जांपल ऑफ अ गुड कोड। सो इट्स डिस्कवरिंग प्रोग्राम्स बाय इटसेल्फ, filling in those holes in those programs and chaining them together so that एक के बाद एक फंक्शन कॉल कर करके हम फाइनली एक अनसॉर्टेड एरे को सॉर्टेड एरे कन्वर्ट कर सकते हैं।